So A is the node, B is the node, C is the node, D is the node, and E is the node. So we have to make a bottom up approach. So we will be discussing agglomerate to HC. It is a bottom up approach. So it is a bottom up approach. So what is AB is a different, AB is a cluster. So make that AB is a cluster, and CD is a cluster. Make it as CD a cluster, and CED is one more cluster. Make CED as another cluster, and these two clusters comes under different cluster. So we have segregated the each community into different types. That is called algorithm. So there is another hierarchical clustering that is known as divisive hierarchical clustering. What we will be doing in divisive hierarchical clustering, in aggregative we have taken from bottom to up, but in divisive we will be coming from top to down. So that is called top to down, top down or top to down approach. We will be using top down or top to down approach. So what we will doing, this all under comes under one cluster called ABCDE. So then ABCD is divided into two clusters, that is AB has one cluster and CDE is another cluster. Then AB is split into two clusters, that is one is A as different cluster and B as different cluster. Then CD is divided into two clusters, that is one is CD and another is E. Then again C is divided into two clusters, that is C cluster as well as D cluster. This is what is called divisive hierarchical clustering. So we will be coming from top to down. So we came from top to down, and in agglomerative we came from bottom to up. These are the hierarchical clustering. So by hierarchical clustering also we can segregate different communities and we can detect the communities. That is all about hierarchical clustering. That is the second property, community detection. So let us move to the another community detection, that is known as label LP, that is known as label propagation. In label propagation there is nothing to worry. We will be giving labels to every node based upon the neighboring element. It checks that, or it will increase its label. I will explain. So node observes its neighbors and sets its own label to be measure of its neighbor. So did you understand? For example, if your girl bestie buys a, for example, sorry, but for example, if your friend buys a Adidas shoes, and he will be showing to you, right? And you will be feel that I have to buy more costly shoes than him. So that is what is known as label propagation. By seeing your friend or seeing your other node, we will be trying to increase ourselves. So that is what label propagation be like. So node observe its neighbor and set its own label to be the majority of its neighbor. So it will set the label which is majority of its neighboring friends or neighboring. So for example, if you bought a Redmi phone and your friend think that we have to buy his friend, he will think that you have to find more costlier phone than him, so he will be getting an iPhone. So that is what it is, label propagation. So let us draw an algorithm for it. What will happen? So algorithm is nothing but just normal nodes are initially assigned with unique labels. So we'll be assigning nodes with unique labels. Nodes are initially assigned with unique labels. I will explain with an example also, don't worry. Unique labels. So in each round, node examines the neighbors and sets its own label to be the majority of its neighbors. Where there is a tie, when there is a tie between, I will explain. So when there is a tie between them, we'll be choosing it randomly. We'll be picking it randomly. So in each round that is known as level. In each round, node examines the label of its neighbor and sets its own label to be the majority of its neighbors. majority of the neighbors. If there is a tie between them, then we will be picking it up randomly. If there is a tie, that if they have the same unique labels, then we'll be choosing that node randomly. For example, if you have two Redmi phones have same specifications, we don't know which one to be chosen, so we'll be choosing the left one or right one based on upon your interest. So if there is a tie, the winner is picked. So I have winner is picked randomly until there is no more chance of label assignments. So we'll be giving each and every unique label to each and every one. So we feel that this one is important and this one is not that much important, and this one is so this one can be neglected. So we'll be dealing with until there is no more change of label assignments. So that is what the algorithm is. Next one is nothing. So I think so let me take an example. So consider this as one example: A, B, C, D. So I have given unique values, that is A is 1, B is 1, C is 1, and D is 1. So I have given initially I have given the every node as 1. So now it's A's turn. So A checks B and A checks G. So it has 1 1. So A tried to change its value. Now now it's B turn. So B checks that A is greater. So it should change to 3. Now C's turn. C checks B as well as D, and C turn is to be more than B value. So C will be 4. And D turn, when D turn is comes, D checks that it should be greater than 2 or it should be greater than 4. So it will be greater than 4. D value will be 5. This is how the label technique will goes on. Now you see that we have different clusters. So we have based upon the unique value, we can classify and we can which has the communities. So this is one of the advantage. Next, fourth one, that is the finding click or anything click, like check glitch. So this is one of the simplest community detection. Usually starts with glitches. Glitches is a subgraph whether every node is connected to any other node. In a k glitch, there are k nodes and k power 2 links between them. So we don't require anyone to know each other within the community. So that is what all clutch deals about. For example, we have already seen what is a clutch example. So let me draw it again. I think it should be, yes. So this is called as clutch. So we feel that this node is A, B, C, D, E. We feel that every node is connected to a different node, but we don't require everyone to know our information. So that is what. So if E doesn't want to know the information of doesn't want to share information with B, then it will be directly removing this edge. And if E doesn't want to share information with where this node come with C, then he will be removing this edge. So that by that way we can easily partition. So glitch is a simple community detection. Usually starts with glitches. Just start with glitches, click or glitches, anything. Glitch is a subgraph whether every node is connected to any other node. So in a k glitch, we'll be seeing glitch later. Next glitch, if there are k nodes, then they will be k power 2 links. That is what we'll be see. For example, if k is equal to 5, Then k power 2 is nothing but 5 power square. 5 square is 25. So there will be 25 links. See this. In this figure, we have taken k as 5, and we'll be having as 25 links. 5 square is 25, right? So 25 links we'll be having. That is what finding clutch. So next last property, that is last community detection technique, is nothing but k click percolate. K-click percolate is nothing but we'll be identifying community which can potentially be overlapped with each other. So we'll be finding the community which are overlapped, and we'll see that, for example, if these two are community, if they are overlapped, we will be seeing that they are k minus link, and we'll be separating each community like this. That is what K-click protocol deals with. So it identify communities which can potentially be overlapped with each other. It is to find by rolling across adjacent cliques. If two cliques are adjacent, if they share k minus nodes, k is a parameter that we need to pick based upon the two, then we expect the community should be. So I think I have explained all this point before. So for example, if is the what we'll be doing in K-click protocol, we'll be dealing with to find by rolling across adjacent k-cliques. So for example, to make this point, if two k-cliques is adjacent, and if they share k minus 1 nodes, k is then k, where k is a parameter, k is nothing but the number of nodes it has, parameter that we need to pick based on how dense or the degree. Based on the degree, we'll be removing that. Based on how dense we expect the community should be. So this is what K-click protocol deals with. For example, if there is a community like this, and there are 4 communities, we have to divide the each and every community. For example, this community shares A, B, C, D. So A community shares k minus 1 nodes, then we'll be doing that. So we'll be merging 2 of the communities into equal parts, which results to, for example, C and B. We'll be merging this as like this. So we'll be having a C, and here we will be having a D. So here we have merged them based upon the interest. Then later we can merge CBD, and we'll be having only A. Then later if there any k minus 1 nodes, then we'll be also separating this two communities. These are the 4 major techniques to divide the to detect community. So what we have learned so far. So what is community detection? Community detection is nothing but separating or detaching two or many communities. In community detection, we have 5 techniques, more than 5 techniques, but basically in many of the sources they are mainly dealt with these 5 topics. So I have explained this. So betweenness edge removal. So I told that when the node is I betweenness, just remove it. Then the graph will be segregated into 2 parts. Then later we have seen the hierarchical clustering. It will be coming from top down as well as the bottom up approaches. If we go from bottom to up, we will be already segregated the clusters into to form a big one, that is A, B, C, D, E, and here it is A, B, and here it is C, D, and here C, D, E clusters. And later we came from top to down, that is where we divided the huge cluster into different clusters to make a small nodes of clusters. Then later we have discussed about the label propagation. Label propagation means that we'll be labeling each and every node so that it will be in unique form for then later. So what will happen in label propagation, one node will check this neighbor node, and it will increase its value. Finding glitch. What happens in glitch? Glitch is nothing but if you remove any edge or any edges between them, so it doesn't share this information, so we can easily partition them. So what is K-glitch protocol? K-glitch is nothing much. We'll be dividing the overlapping clusters. That's all for community detection. I think we have covered all those things what we have started with. So properties of real world network is completed. A random graph module is completed. What is the properties of real world network? There are three properties, that is power law, cluster coefficient, as well as average path length. Random graphs are of two types, binomial and uniform. SQL small world networks are three types. I have given the EWM and WSM models, different three models. And PALM, I have explained what is a PALM and what is an example. And community structure, I have explained types of communities, overlapping communities, non-overlapping communities, style community, etc. And community detection, I have explained the 5 techniques. So that's all about today. And I am unable to make sure that to cover these topics, that community evolution and community evaluation, I didn't get any resources to make video on this, so I have skipped this two topics. Later in offline we can discuss them. So thank you.